x is given in terms of y. X is 1/2 e to the y plus e to the negative y, and y go from 0 to ln of 2. And since we rotate about the y-axis, the radius is x. But we recognize that 1/2 e to the y plus e to the negative y is actually the definition of hyperbolic cosine. And so dx dy is hyperbolic sine of y. And then when we square it, we have the square of hyperbolic sine y. And then in the arc length formula, we need to add 1 to the square of the derivative. And so 1 plus hyperbolic sine square y. But using the hyperbolic identity, this is actually hyperbolic cosine squared of y. So 1 plus dx dy squared is hyperbolic cosine squared of y. And taking the square root of this, we end up with hyperbolic cosine of y. And so the arc length is just simply hyperbolic cosine of y. The surface area is 2 pi. The integral goes from 0 to ln of 2 along the y-axis. The radius is x, and the arc length ds. But x is given in terms of y, specifically hyperbolic cosine of y. And so we replace x with hyperbolic cosine of y. The arc length is the square root, but we're simplifying this already, which is hyperbolic cosine of y, and then dy. Simplifying the integrand, we have hyperbolic cosine of y squared. We can just leave the answer in this form, but we can also rewrite it in terms of exponential function. Hyperbolic cosine of y is e to the y plus e to the negative y over 2. We circle back to the original expression, x equals cosine of y, which is 1/2 e to the y plus e to the negative y.